So our second topic, it says AWS 101, but I would say it's more like a cloud 101, just some simple concepts and ideas of how it is to work with the cloud. As it was mentioned before, the idea of our classes are to just give you guys the path of what you should be reading and researching from here that will help you to become better DevOps cloud engineers. So you can easily find that content on the internet. That's not the main point here. And one other thing that you will notice is that from now on, all our classes will be markdown Git. So there's no formatting anymore. Like the first class that Dennis did for Git, we figured out that the effort wasn't really good enough. Like it took too much time to make that Git class with that pitch thing that makes his slides on Git. But it's also hard to maintain. And the idea of this repository is that people can come, communities can come and create pull requests with not just for the submission of the exercise, but also for the content. And then it's much easier if we have a plain text with a basic formatting to keep with our content. So it's not going to be slides anymore from here. It's just plain markdown Git. So some general cloud concepts. The cloud itself is just a place where you can pretty much have infinite resource. You can create any amount of instance with any amount of CPUs and RAMs. It's nearly infinite. Of course, not infinite, but nearly there. And it's all virtual, like virtual machines. But it's still a computer running somewhere. It's just that there's a provider that is managing the hardware and some part of the infrastructure for you. The cloud also helps with elasticity. So, for example, if you have a server that was originally configured for hosting 10 users, and then suddenly let's say it's an e-commerce. Suddenly your e-commerce is doing well, you need more 15, 20 users. If it was on a traditional environment, you would have to shut down your server, install more RAM, or update your CPU or something like that, or even buy a whole new server to host those new users. And with the cloud, it's with a few clicks, you can have an upgrade of your hardware, or you can even automatically scale up if you need. For example, in one night, you release a new promotion, and then you get the 15, 20 users on your website, and then your cloud environment will automatically scale up, create more instance, more virtual machines, more virtual servers, and will hold all those users that are accessing just at that time. And then once they leave, the promotion ends, your servers will go back to just one. And then it goes to the next point of the general cloud, which is it's cheap because you pay just for what you're using. So instead of buying a supercomputer that can host up to 100 users, but then you usually just have 5 users on your website, but you have paid for that for a big server, whereas on the cloud you'll be paying just for a small server that hosts 5 users, and then if you need, you pay for more. If you don't need that CPU resource and RAM, you can just scale back. And that also helps you to innovate, because you have pretty much an easy access to very powerful resource that you can use if you need, or otherwise you won't, and then just pay for that. That enables quite a bit. You guys probably have been seeing around how fast machine learning and AI things are going. That's mainly because of cloud, because of how easy it is to access resource these days. So probably 10 years ago would be pretty hard for someone creating a new machine learning algorithm, and I only have this small server, and will take 6 months to run this algorithm and give me the results. Whereas today, you go there and pays for a super NASA computer, maybe $10 per hour, but then in 5 hours you have your results, where will take like 6 months before. So that is helping a lot how people can improve and learn more. So when you are architecting an application in the cloud, you need to, the first thing that you need to think is this pet versus cattle thing. Does anyone have heard this before? Cattle versus pet. Anyone doesn't know?
Yeah, I already heard that.
Yo, what's up?
I heard that.
Oh yeah.
I heard that my first web service used to have the Looney Tunes names, you know.
Oh yeah. Yeah, my ones are all Star Wars related, so I would just call it a random Star Wars character. But that's the idea. Like before traditional environments, you would normally have pet servers. What we call pet servers, which is you literally give him a name, so you call it something, and then you will have different applications configured there, patches, versions of things running. You know what hardware is running there. You do upgrades to it, and then the main part is if it fails, you probably will have a big impact, and you will have to replace it because it's doing a main part of your application. So you have to replace it, and you have downtime. Whereas cattle, the idea is that you have many instances that looks the same, and if you lose one of them, you won't have a big, not that it won't have an impact, you still can have, but it will be a more controlled problem. And yeah, that's pretty much it. Another thing is, one way of thinking on cloud is try to create your application on a independent way. So as much as you can create your application that is running on the cloud that doesn't depend on other systems. When you have some downtime in one part of your system, it won't affect the others. The cloud helps you with that because it's with the 4 points on that list, the automation. The automation helps us to duplicate resource around your environment, because you can just run a piece of code and you have that the same again, or maybe you just change a few variables and you have a different version of that same resource. But then with automation in place, it's quite easy to create independent systems, and then you reduce that blast radius if something goes down. And one last point is ephemeral environments, which is with automation, we tend to create environments that once your automation create an environment, you can't change anymore, because then you can make sure you guarantee that whatever is running at that time, it's based on your code, on your automation. And then your code, your automation becomes a source, the only source of truth of what is running on your environment. So you can always, instead of going to your AWS account and keep looking into the console or any other cloud provider, keep looking in the console, see what is running there, what you created, what people created or not. You can just go to your code and see what was created from there. And then this idea of ephemeral environments is, if you need to change something on that, you will update your automation, and then you will rerun and recreate your environments based on the new code. Because I can give one example here that will show some ephemeral environment concepts and pet versus cattle. Your automation creates 3 instances in a cattle way. So all the 3 instances are the same. And if you lose one instance, your automation will automatically come up and create another one. So we'll make sure that you will always have 3 instances. But then you find out that your application is not doing well in one part. For example, back to the e-commerce. I'll keep using an e-commerce as an example. You found out that there's a banner that is missing the image. So you jump into your server, into one of these 3 instances, and you fix that banner, and then but if you jump into that instance and you fix that banner, well, first point is that it won't reflect to the other 2. So it's not a full fix. But let's say you go and fix all the 3 instances manually, but now you don't have more. Your instances are now pets because you have touched it and you have customized it. And then if you lose one of those instances because, let's say, too many people come join your server and then your server stopped working, you lose one of those and your automation will create a new one. But when your automation creates the new one, you won't have that fix on the banner. So that's the difference of the pet and cattle, and also showing some ephemeral state. So the idea would be you go and fix your automation, and then you recycle your instance with new instance with that problem fixer. Anyone have any questions up to here? It's fairly simple concepts, but again, we have people here that never used cloud before, and we need to go through this path with everyone. Some of the benefits of the cloud. Normally the cloud providers, the main cloud providers in the market are AWS, Google Cloud, and Azure. All of them, you can pretty much do the same within the platforms. Of course, some of you have to do on a different way, but essentially you can do the same things on any of the cloud providers. Our content will be mainly focused on AWS services. We're thinking in the future to maybe add more about the other cloud providers, but for now it's all AWS. The cloud providers, they offer services called managed services. Some of the features are called managed services. What that means is, for example, a database. If you are creating your e-commerce, you will need a database. Traditionally, you will have one server where you're going to install your MySQL or your Postgres or any database that you like. And you have to maintain that. You have to install patches on that. You have to update. If it crashes, you have to go there and fix it. You have to work on improving the performance of the database and any other tasks. So you have to manage it. It's essentially a patch. AWS offers many features as managed services, which means they will manage the maintenance of that database for you. For example, it's on AWS, you have RDS, which is a manage MySQL or Postgres and some other flavors of database. And then the only thing that you can do, that you need to do, is you create your RDS database and put your data there and start consuming. The whole thing, AWS will make sure that that database is always running. They have their SLA, of course, but it's probably like 99.9% of the time on. And they will offer you options of doing backups. You can choose what is going to be the window that they will use, that they can use to make updates to your database. And that's essentially a managed service. So it's a service that the cloud provider will guarantee that the resource is up and running for you to consume. You don't have to maintain that. As a rule of thumb, you always try to pick managed service over you having to do by yourself. Like what other way we would do on cloud would be, I create a virtual machine and I install my SQL server there and start consuming, but then I have to maintain it. with cloud, we will try to always pick managed service over having to maintain by ourselves, because I'm a developer and I'm just trying to focus on creating this e-commerce here. I don't know much about database, and I just know how to create my tables and put my data and read my data from there. I don't know how my SQL server works, so I'll just pick this one. Maybe it will be a little bit cheaper if I run the database on an EC2 instance instead of paying for a managed service. But in the future, with labor and the issues that you have on the way, it's going to be cheaper having the managed service, that is for sure. Even big enterprise companies, like highly regulated environments like banks, are opting to go with managed services as much as they can. And they have the capability of running by themselves, all those services. It's easy to test new solutions on the cloud. It goes back to the general concepts. It's super easy to go on the AWS console, get an EC2. EC2 on AWS, it's a virtual instance, like a virtual machine that you can use on your local PC, like VirtualBox or something. Or if someone is from traditional infrastructure, something like Citrix or VMware. So EC2 is the virtual machines on AWS. With a few clicks, maybe less than a minute, we can have a virtual machine running and spin up a web server and put some code and have my e-commerce up and running. Like, this is what cloud offers you to make simple to get started. And again, you pay for what you're using. But I can't stress enough on this pay as you go. Take care of that, like be careful with that, because you have your credit card attached to your account. Whatever you create on your AWS account, you'll be charged for that. Most of the things that we are going to cover on this course are within the free tier on AWS. That means most of the features on AWS has something within the free tier, which is, for example, an EC2 instance. You can run an EC2 of the type small, I think, or micro maybe.
Teach you the micro ones. Teach you
yeah, you can run one micro EC2 instance for 24/7. Yeah, for the whole month, it's fine, and you won't be charged for that. If you run the second one, you'll be start paying for the second one. So most of the service have some sort of a free tier. We will have some exercise that will go over the free tier. I think it's a small price to pay to learn. You might spend a few bucks during the course. It's up to you. All the exercise that we have that does need to go over the free tier, we don't make it mandatory to make. So it's up to you to do it or not. We highly recommend it doing, even if you need to spend a few dollars. One thing is that you can have in mind is if you forget something running and you get charged $100 at the end of the month, you can try to open a support ticket with AWS, say that you are studying, you're trying to learn about the platform. Again, this is not a guarantee. I'm not saying that they will give your money back. You can try to ask. We have seen it happening before. What I have to say, and we will keep saying that every time that we mention about one exercise, is you create your research on the console. Maybe on the first time, take notes of everything that you are creating on a piece of paper. And then at the end of your exercise, you go back and delete everything, remove everything. The idea of cloud is automation and creating and deleting research. So if you don't have the requirements of having a virtual machine running 24/7 there, delete it. Then next day, but then in the middle of my work, next day you come again and you do it again, all from the beginning. That will also help you to learn. You have to redo a few times. So don't forget things turn up. Last term was pretty okay. We have a few hiccups. Someone forgot a big database running, got charged $200 over the weekend. It was good that AWS give credits back, but let's try not to do that. And if we need to spend a few dollars, we will. So there's no upfront costs exactly for this point. So for having a billing cycle, which is month by month, and I will only pay for whatever I use. There is a few exceptions for what I just said. For example, you can commit in a few AWS services, you can commit for 1 year to use that, or 1 to 3 years to use that service. You need to understand about availability zone and regions. That's the basic concepts of clouds. That's even in concepts of clouds too, availability zones or AZs and regions. So one AZ, one availability zone, you should consider like a data center. If you go into the official description of what is an AZ, they will say that it can be one or more data centers. They don't, it's not this, how do you say that, discrete? It's like, it's not, they don't share that information, like it shouldn't matter for us, but essentially it could be one AZ, it means that it's one data center or more. But within one AZ, it's considered a local networking. When we write down this page here, there was 69 AZs over the world. It's probably more than that. That's been a few months. They are always creating new AZs. And regions, it's like a set of AZs. It's at least 2 AZs to make a region. And maybe 1 or 2 regions in the world have 4 AZs. Normally, it's 3 AZs in each region. There is 1 or 2 regions that have 2 and 1 or 2 regions that have 4. When they plan the networking for the regions and the AZs, they already plan for up to 4 AZs for that region, if in the future they release more. So a region, of course, will have more than 1 data centers across that geographical region. And they guarantee like a physical distance between the data centers. So in case of some, like the data center gets on fire, won't be anywhere close to the other data centers. There was 22 regions when we write down this a few months ago. I think there wasn't, I think I heard about 1 or 2 new regions since then.
Yeah, the numbers are 76 and 24 now. So 76 AZs and 24 regions now.
Yeah.
So
There was 2 new regions.
Hey, Kyle.
Yes.
Do you know what's the minimal distance between AZs?
Between AZs, I don't think they share, but regions, oh, sorry. I think it's 150 kilometers, something like that.
Cool.
I read somewhere once. So when you are planning to create something on the cloud, you try to have, you use what the cloud helps you with the best, which is the high availability, the ability of having your resource running geographical separated. So you have high availability on your resource. So anytime that you architecting a solution for running on the cloud, you think on running in at least 2 availability zones. So in case one AZ is down, you still have your work running in another AZ. Is it possible for a region to go down? I've seen it happen once. So the region, Sydney region, was totally down a few years, 4 or 5 years ago. There was like a big storm, and the whole region was down for a few hours. The responsibility of AWS and any cloud provider goes to the platform level. So when you create your virtual machines on the platform and you have your software and your backups running, it's your responsibility to take backups of that and have contingent strategies to get back working. So for example, if a whole region goes down, your application is down and you lose data, it's like you need to have backups for that. You need to cater for that. So you need to have like disaster recovery plans in place when something goes down. So it's very unlikely that a whole region will go down, but it can happen. If you're dealing with maybe something from the health sector that needs to be like, it can't go down, you might need to be looking not just on high availability between availability zones, but also between regions. And then we kind of have a problem because in Australia, we have only 1 region with AWS. I'm not too sure about the other cloud providers. I think Azure is the only one that has 2 regions in Australia.
And Google should have the next one by the end of the year as well.
Yeah, Google is close to release a new one. AWS is always saying as well that we'll have another one, but you can use another region. For example, AWS has another region in the Singapore, I think, which is not too far away, but your company might have problems with the data sovereignty. So there are some types of companies that you can't have your data out of the country. So you also need to think about that when you're architecting for the cloud.
And would there be any data transfer charges and extra cost as well? Yeah.
Yeah, that's a good point.
Multi-region.
So when you are sharing data between VPCs, which is topic for the next class, so maybe like from different data centers, your virtual data center in the cloud, you have costs for that. And I'm not 100% sure if the cost is higher if it's within the region, and it's more expensive, it's inter-region traffic. But there are costs. So when you're actually also planning your application, if you have it in different regions, you definitely have costs when you transfer data between one to another. That's a good point. And we also have edge locations. So edge locations they're not necessarily a full data center. It could be just a set of hardware from the cloud provider in a commercial data center. They just have a presence on that commercial data center, and they use that point to cache customers' data. So you see that there's quite a few. That's probably more today. Do you have the new number, Kiko? I would say that's at least 10 more over these 3 months. So they are constantly releasing more and more and more. So you guys can see here. There's some pictures. Regions are the blue ones. Australia, we have only one. It's in Sydney. It's called AP-Southeast-2.
216.
How much?
216.
So, well,
11 more, yeah.
I guess 10. Regions coming soon. 2 of those is probably already done. And we don't have the edge locations map. But for example, if you want your e-commerce to be accessible from people in US, you will have some sort of a CDN or content delivery network in place. In AWS, the offering is called CloudFront. So you configure your application to be delivered by CloudFront. It's just like something on top of your application, and customers will come through CloudFront before hitting to your application. And what that means is if someone from US access your e-commerce, the first time that they try to access will have to go to the what we call origin, which is your data center, where is your server running your application. But then that information will get cached on this edge location in US, the closest one to where the customer connection came from. And then the next person around that area that tries to connect your e-commerce will grab that information from the edge location. So you won't go every time back to the origin in Australia to access that. So those are the edge locations. Edge locations also helps to upload files. So it's kind of a mesh network connection of the AWS data centers, and they use that to improve the speed and the transfer of traffic between the whole world. There are some new use cases these days for networking related as well. So you can expose your traffic, your network connectivity using something called global accelerator to other parts of the world in a cached way as well that use the edge locations. We won't go too much into this one, apart from having a CloudFront to expose some services. Any questions until here? That was a good point about the price. I think we should add some more here. So every time that you communicate on AWS within your virtual data centers, you have some traffic costs. And when you send data to AWS and when you download data to AWS as well.
Yeah, it's like specifically, let's say if you have two S3 buckets that you are syncing across the region, I remember you have to pay a little bit extra for that data transfer, that kind of thing.
Yeah.
Do you need to know all this information for AWS XM?
Yes, for this certifications, yes, it might ask you what is charged and what is not. Like it's really hard to understand, really know which one is charged or not. Like, for example, I just said that when you upload data, it's definitely being charged, but I don't think you are charged when you're downloading data from AWS.
It's
But
the other
also-
way around. They don't charge you to put data there, but they charge you to download that data from there.
Easy to get in.
Yeah, that's the idea, because you're already paying for storing the data there. But yeah,
And it seems like a really low cost, but it's not. It's really expensive to get the data. Those traffic can get quite expensive when you are talking about thousands of terabytes or like petabytes of data. It can get like super expensive. Some of the AWS, so you can see AWS has quite a few services, over 130, and they are constantly creating new ones. That's probably more than that already. I'm gonna jump on my console here. So this is the AWS console. I can see some information about my account, and if I need to go to my billing to see, they can provide you some forecasts of how much you're going to spend on AWS this month. It helps you. There is one exercise around that to do this week, which is creating some billing alerts. That's very important. Do it and don't delete afterwards. You don't need to delete the billing notifications. And then if you click on services, you see all the services that AWS can offer you, and you can also type here because it's quite a few. And for example, I want to create a virtual machine. I will just look for EC2, and then it will show me my EC2, the EC2 service. If I click here, we'll go to the EC2 management console, where I can see my instance running and all services related to EC2. As mentioned, it's quite a few. We'll go during this course, we will go over the most common ones that we use 99% of the time to create a project, to work on some scenarios that we've seen around, like compute, EC2, virtual machines, storage, S3. It's sorry, I forgot what I was going to say. So S3 for storage, database, we have a few types of database. What else? IAM, that it's what controls how we access AWS, users, roles, groups, and those kind of things. We will have, the next classes will be around each one of those services. This is the innovation pace of AWS. So we have here up to 2018. So you can see that in that year, they released 1,800 new things. New things can be a new feature, a totally new product, or a feature for a product, or just a bug fix, or just updates in general. But essentially, they do more than 10 updates per day. So it's quite a lot to keep up. So these whole new words that, if you guys are not into the DevOps world yet and just wanting to start with, it's really hard to keep up with information. You sleep, next day there is 20 new things in the market, and you have to keep studying and studying and studying. AWS itself will release 10 new things every day, just to be aware of. Also, I was mentioning that some of the main services on AWS for computing, we have the EC2, which is the virtual machines in the cloud. ECS and EKS are orchestration tools for containers. ECS is the AWS own implementation of an orchestration tool for containers. We'll have a look. We'll have a class just about containers if someone of you guys never worked with that before. And our project is based on containers. And EKS, it's the Kubernetes management service from AWS. We won't touch on Kubernetes on this course. We will talk about ECS, but not EKS. And Lambda are the serverless function. We'll get into the topic of serverless as well. It's our last class about that. Database, few options. We have RDS, which is relational database service. We have like MySQL, Microsoft SQL, Postgres, and a few others. Elasticcache, just doing some caching for database, main cache, Redis. DynamoDB, it's a NoSQL implementation for AWS, their own implementation of NoSQL. RDS, they offer it in 2 ways as well. We'll get more deep into that later in the course, but essentially they offer the traditional way, not the tradition, the official way of Postgres and MySQL, but then they offer one AWS managed, which is called Aurora. Essentially, it's cheaper, has more features embedded to that price that you're paying for, but it's not fully compatible as MySQL and Postgres are. If you have some really old traditional applications, you might have issues into it. What else we have here? DocumentDB. It's a MongoDB MongoDB services on AWS. It's a managed document database. I don't really know the difference of MongoDB versus NoSQL. Dennis can help. No?
Yeah. Well, MongoDB is a NoSQL database. It's document-based. On the other hand, DynamoDB is more, you can store documents as well, but it's more of an attribute-based key value. There's Elasticcache, which is a key value. All of the 3 are NoSQL. There's Neptune, which is a graph database as well in AWS.
That's not even here, but it's just that we don't feel it's more advanced than the GraphQL. For the developer guys here, mainly if it's front-end developers, maybe have used GraphQL before, but those are more traditional ones.
But this is like DocumentDB is like MariaDB and DynamoDB is MongoDB, something like that.
Yeah. My question was more like, what is the difference on MongoDB to NoSQL? Because they are different, like not Mongo, but managed DocumentDB to NoSQL, because they're very similar.
Both are NoSQL.
Yeah, both are NoSQL. And Dynamo is document-based. In the end, it will store the data types along with data, so very similar.
Just trying to get you guys to talk, because no one asked questions. Storage, we have S3. The space for S3 is unlimited, so you can store virtually anything on S3. So just be prepared to pay a lot of money for that. Again, if we are just using for maybe a gigabyte of data, something like that, you might pay 50 cents in a month, $1 max. So if you do your maths, you see that S3 is cheaper than paying for maybe Google Drive, for example. It will be cheaper having your files on S3, but then it's not a nice UI. And Google Drive doesn't offer you just a space, but also not saying Google Drive, any storage online in the cloud. So they're not just giving you the space, but also all the apps and software that you can share your files. And whereas on S3, they will store for you, but they won't have a nice UI. It will be more hands-on. You have to operate that. But it's unlimited storage. You have a few characteristics on that we'll get into more details later in the course. EBS, it's kind of virtual hard drives for your instance. So it's called elastic block storage. It's when you create your instance. Normally, when you create your EC2 instance, will come with a drive attached to it. But essentially, if you delete that instance, you will lose that drive with it. So a way of keeping your data on that storage is you add an extra EBS volume to your instance, and then you mount that volume to your instance, copy the files to there, because then they are independent things. If you delete your instance, you still have your volume. And the EFS, kind of the same idea of having your files not on your instance, but this one is a network shared. So when you might get an example, if you're working on a company, you have your shared drive where you can have your files there, and if you lose your computer, you won't lose your files because it's not actually on your computer, it's saved somewhere. EFS, it's a service that is across availability zones, and you need to have it configured for different AZs if you want to access from your instance to that. Your instance needs to be running on the same AZ as where your EFS is configured. So it's we'll have a few services on AWS that have this characteristic, which is to be available to all AZs. You actually need to configure the service to be run on all AZs, and of course we'll pay more for that. And if you would run just in one AZ, but then if you run in just one AZ, your instance will also need to run on that same AZ, otherwise they won't have access to it. And then networking, the base for any of those instance, EFS, what else? RDS, you need networking, you need IPs, you need subnets. So this is what essentially AWS offers for you. You have your VPC, which is your virtual, it's called virtual private cloud. It's like your virtual data center. It's the first thing that you create on your, when you create your AWS accounts, they will provide you a default VPC. And then that helps a lot for people that are starting with cloud, because they don't need to think about that. So if you are fresh to AWS and never used before, you're gonna create your account. You're gonna go straight to EC2, which is the virtual machines. You're gonna create one. The wizards will give you all the details. You start your instance and you'll be able to access it. And you say, wow, it's so simple. But then there's a lot that has been done for you in the background. We are not going to use the default VPC on this course. So we're gonna create from scratch all our infrastructure, and we'll show you how to do it properly. So when you create your VPC, you have to set up all your subnets and security groups and route tables, and it's quite a fair bit of things. It's the networking. It's a fair chunk of content on the cloud to understand. We are hoping that the infrastructure guys from the group to help the developers with the questions that might come. CloudFront was mentioned before. It's a managed content delivery network solution. Route 53, it's a managed DNS solution on AWS. When you're dealing with infrastructure networking, you will need DNS. API gateway, again, on the serverless service. So it's a way of exposing your functions, your Lambda functions. Management, CloudWatch for logs, alerting, and what other one? And metrics. So with CloudWatch, you can get information from your virtual machine, like how much of RAM is being used, CPU, or even custom metrics, like how many users are connected to your service at this point. Based on those metrics, you can create alerts, and the same service, CloudWatch, you can grab logs from the services that you are running. CloudTrail keeps track of all the API calls that that is being doing on your AWS account. So anything that I do here, it's me doing API calls. So EC2 running instance, I'm literally just sending a command, please list my instance running. So this probably 9% it's tracked by API calls on AWS, and the CloudTrail service keeps track of that. So you can see if people have created EC2 instance, when was that, what user did that, or what role did that, and those kind of things. CloudFormation, it's used for infrastructure as code. So automation, when you want to create, there is two ways of creating things on your AWS, not two ways, but a few ways of creating. One of them is console, what we call ClickOps. This term is being around now. So ClickOps is just coming here, running instance, launch instance, and just going through here like a wizard. Or you can create through code, or what we call infrastructure as code. You can also use the AWS CLI, which is a command line tool you install on your PC, and then you can run commands to do the same things. AWS on offer is the CloudFormation one. So you create scripts, and then you consume those scripts on your AWS, and it will go and create your research for you. This course itself, we are gonna cover Terraform instead of CloudFormation. It's just another tool for creating scripts to create research in the cloud providers. Systems Manager, there is quite a few tools inside this feature. So with this one, you can remote access instance, you can run commands, you can remote run commands on instance. For example, you need to, I haven't used much Puppet and Chef and those tools in the past, but essentially it's something like that you can do with System Manager. For example, you want to install the software A in 100 servers. Instead of going to 100 servers manually and installing that same feature, you create a script, and then you use, for example, System Manager to select this group of 100 servers, and then you just say, run this script for me on those 100 servers, and it will go install for you. You can do that with System Manager. And you can also store parameters and secrets into these two. And then what is a parameter? What is a secret? It's just something, for example, you have a username and password for a database, and you don't want to have that on your script. So you create a parameter or a secret on the Systems Manager. It's something called SSM parameters. You create your database password there, and then when your script runs and it's going to create or access your database, we'll communicate with the Systems Manager service, and we'll grab the value for that password, and will use on your script, so you don't need to have it there. Messaging services, SKS, SNS, and SES. This is mostly for decoupling applications, as mentioned before. So, sorry, it's ringing my phone. for example, instead of one application A communicates directs to application B, you put something on the middle, and then application A sends that message to this thing on the middle, and then B can read from there. That way, if you try to send a message from A to B and it fails, it's just harder to keep track, and you might lose data when you're doing that. So those services are for that. SKS like to create this kind of queue between services. Then it's a point that you can send messages and other applications can consume those messages. SNS can be used to trigger alerts, to send emails to others. And SES can use to receive and send emails like is it considered a managed SMTP server? No?
SES?
I think it's considered a SMTP server.
Yeah, it's an SMTP. It's just not for end users. It's more for sending emails than receiving itself, I guess.
For example, you have an automation. You have an application that needs to send emails to customers. You can use that service to generate those, to send those emails. Security and compliance, IAM, Identity Manager, mentioned before. It's to control how you have users, roles, groups, and permissions and access on your AWS accounts. Certificate Manager, it's to deal with SSL certificates for your applications. We'll get into that in the, close to the end of this. KMS, it's to encrypt data. So you can create keys that AWS will manage for you, or you can import your own keys if you know what you're doing. And then you can use those keys to encrypt your data on the various services on the AWS. And WAF, it's a web application firewall. So remember CloudFront, something that you put on top of your application, then customers will go through CloudFront before hitting to your application. So you can have some sort of web application file on the CloudFront and then have rules, for example, looking for cross-scripting, SQL injection, and those kind of things. And a few of features for development, which it's quite a few on AWS. There's always coming new ones as well. So code commit, code build, code deploy, code pipeline. Those essentially we will not be covering here. Code commit, Git, GitHub. We will be using GitHub instead. Code build, we will be using for builds, deploy, and pipeline. We will pretty much be using GitHub actions for any automations that we might have during the course. And that's it. Any questions? Yeah, all our classes are going to be like that, like massive theory classes, and it's not really fun. We'll try to do some demos and show some commands, but there's no time to do a full exercise together with you guys. Like we have 24 hours to give to share content with you, so it needs to be like that. We give the theory, we answer questions, and then next step now is you guys go and do the exercise. So you will have hands-on AWS exercise to do. It's quite simple, like creating a virtual machine, accessing, creating a S3 bucket. Even if you don't know about that, like I have no idea how to create a bucket. No one have shown me, but that's part of the course. Like that's part of the DevOps Academy. To be able to work with DevOps, you need to know how to use Google and look for the answers that you need. So, and we will be on Slack to support you guys on that journey. So you start doing the exercise, you have questions, Slack, keep asking on Slack. As Kiko mentioned, if we are quite fast to reply, you will be surprised how fast we can reply to you. Sometimes it can take some time, but normally it's quite fast. If you need, we can do some one-on-ones of you guys. We jump into a Zoom call and help you with that. And we are also trying to see if we can make some mentoring sessions that will be mainly for technical stuff to go through the exercise. So it's not a class, it's not mandatory. You can join if you are free or not. And then we might have 2 or 3 people to help doing some pair programming and helping out. Otherwise, if no one has questions, that's it.
Ekayo, one question. What is the channel the best channel to post something on the Slack? Like there's academy, there's public academy, and there's project groups. Which one would be the best?
Yeah, so for the guys that are part of the people that are on the Zoom class here, there's 16 of you. You are part of the DevOps Academy term 2. We are committed to review all your exercise and help you as much as we can. And then you guys should use the Academy June 2020 for sharing your questions, because then we know where our priority needs to be. And people that are watching from as listeners, which is quite a few people, thank you for everyone to join. There was a point that was like 35 people connected. You guys, there is a public channel on the Slack, Public Academy, June 2020. Share that. If you guys wanna, if you guys wanna help out on the public one as well, like do some sharing stuff, feel free to. It's just that whatever it's on the private channel will have more priority. And it's the same for the exercise on GitHub. We'll see how it goes. It's going to be quite a lot of PRs coming up to our way. So it's probably around 80 PRs per person during the course. So you guys are 16, so it's quite a few. So that we will need to review. So our priorities for people that are on the Zoom, but I'm quite confident that we'll be able to cover anyone that is doing the exercise, even the external ones as well. And one more point, you guys are also free to review other peers. So it's actually welcome to review other people's job and put some helpful tips and be picky, complain about stuff. That's how we will learn through the course.
Mm-hmm. Hey, Kyle, one last thing. Can I share my screen?
Go for it, man.
Yeah, as Kyle said, it's fast-paced. Don't worry. Just try and do the exercises and will help. That's an example of an exercise from this class 1. So here you'll find instructions. For example, this one is for creating an S3 bucket and uploading a file to it. Usually we include some tips on how to achieve that, especially if we haven't covered the subject yet. And yeah, the solutions are not big, just a couple of lines. So yeah, it should be all right. This class on AWS touched on tens of services, but from class 2 on, we are going to dive a little bit on a couple of them, little by little. We're going to show commands, open the console. So yeah, don't worry. In this exercise, we are not going to ask everything about all of the services.
With respect to the exercises, do we have to create branches for every particular part?
Yes. Okay. The same process I showed in the Git class. You need to follow, creating branches for each exercise. And in this case, there is an instruction here. To submit this PR, you need to copy the contents of the answer MD and create a README file and put it in the folder you created with your GitHub username. It will be a matter of just copying this file, renaming it, and answering here with the commands you used to upload the file to S3.
And please do one exercise per branch. Don't commit 2 exercises on the same branch. That will help you guys as well too, because what normally happens is you create 2 pull requests and the change will be across all the pull requests, and then we merge one and we'll have conflicts on the other. So create a branch, work on exercise A. When you feel it's right, commit, push to the orange, create your pull request. While you wait to us to review, you go back to master and branch to exercise 2, and then do it again.
Yeah. And for next week, we're going to talk about more what DevOps is. As you saw, we did an introductory concepts, networking, and one of the basic services. And
It's fine. Try to search it, but if you have some troubles, try to go to the console, see exactly what you need to create through the console. That will make it easier for you to go with the CLI to deliver the exercise itself. Because through the console, you're gonna see all the steps that you're gonna need to do in an easier way and let's say baby steps way, instead of in the command line. It's kind of, you need to know a few things additionally. So go to the console, do that, what you need to deliver, and then just redo using the console, the CLI. It's probably going to be easier if you're having some troubles with the CLI.
Yeah, it's a good point. Do it on the console, the click ops that we said, and then when you know what you need, then you try to do on the CLI. Another thing is, if you find some useful material that helps you to complete an exercise, feel free to create a pull request, not for this exercise submission, but for our content as well. The content is all open source. If you find any misspelling content that you feel that is not right, you want to complement or add more stuff, feel free to send a pull request for us. We actually want you guys to do that. The other term helped us quite a bit to shape the exercise, the content itself. Anyone else? Any questions?
Kyle, do you usually use all those servers in a project, or should I focus on a few specific servers? I mean, for the rest of my life,
yeah,
to know.
That's exactly the idea of this course. Like as I said, not the content itself, but what you should study for. We'll be showing everything that we show in these next few classes. You should focus on that. That's the 90% of our daily jobs. It's around the tools that we'll be showing on the next few classes.
Okay, like the core. Yeah. Okay, that's fine.
And it will be quite a few. Even if it's just a small set of features, it's going to be quite a few. And if you guys are,
it's about 20.
If you leave your exercise, what is that, sorry?
I think it's about 20 servers that we're gonna touch during the course, at least, which is quite a lot. And
if you miss a 2 weeks period on your exercise, it's going to be hard to catch up later. It gets overwhelmed quite quickly.
We've seen it.
But there is around 70 exercises the whole course to do.
Yeah.
And even if you are master Jedis on Git, I expect you to provide the Git exercise as well. You need to do all exercise. We need that board all green. What is the name? All green policy, because
all green policy.
All green policy.
It's everyone's. If 2 of you don't do it, we'll have a big red on that, and it's gonna look bad.
You guys gonna see that chart every week on the channel. So yeah.
Yeah, we need to make it green.
It wouldn't be much different for me because I'm colorblind. So red or green, it doesn't matter.
Do they use a different color? What colors can you?
I can do different types of shades as well. Shades of gray.
Hey, Fernando Braga, is that live on Melbourne CBD?
What's live? Yes, it is. Yes, yeah. Behind me is just Elizabeth Street.
Yeah.
Bloody codes.
Hey guys, good to see you all. Nice to meet you all today. Hope you have a good week. I'll see you in 2 weeks.
Nice to meet you guys.
Thank you.
Thank you guys. Thank you so much. Thank you all.
Cheers, guys.
Bye.
Cheers. Bye.